Hi ladies, Mr. Sullivan. Let's hope this video actually records correctly this time. I was recording it last night. And I realized when I was about to upload it on YouTube that the audio wasn't there. So let's hope that it works today. So this is the first time you've seen me with like two screens, but what we're going to be doing today is we're actually going to be learning how to factor. You have probably heard the word factor before when you've heard greatest common factor, but you've never actually really done the process. So what we're going to be doing today is we're actually going to be learning how to factor a polynomial using GCF. So today's learning target is, I can factor a polynomial by using the GCF leftover polynomial technique. Give me the heads up. I do have a lot of cool tricks and all those nifty stuff, but Miss Daniels came up with this one. So if you ever see Miss Daniel on a Zoom or in the hall, make sure you thank her for this one, because let me give you a heads up. Every single student who does GCF leftover knows how to factor. So before we even go into what this technique is, we're going to go over prime factorization. So you did prime factorization. I know you did prime factorization. You didn't do it in my class, but you did it somewhere along the way in your mathematical journey. So before we go into prime factorization, this is what prime factorization looks like. This is what you did when you first learned it. Again, prime factorization, we're going to go over it. Before we go over it, a prime number is simply a whole number that is greater than 1 that cannot be made by multiplying other whole numbers. So I'm going to zoom in on this sheet. So if I look, I can say that the number 17 is prime right here. I can say the number 17 is prime. I can say the number 7 is prime. I can say the number 37 is prime. I can say the number 19 is prime. And the reason why I can say those types of numbers are prime are because the only numbers that go into them are 1 and that number itself. So for instance, 1 times 37 is 37. 1 times 17 is 17, and so forth. Prime factorization is the method you use to find which prime numbers multiply together to make the original number. When using this technique, we are given a term. Note, I'm not saying number, we're given a term. And what we want to do is we want to find all the numbers that can multiply to it. Here's the nice thing. Every single number's prime factorization is unique. So you can break it apart in as many ways as possible, the legal ways, obviously, and you will still get the same exact answer every single time. So what we're going to do right now is we're going to use prime factorization to rewrite these terms right here. So our first example we're going to do is the number 12. So if I look, I want to ask myself, what are two numbers that multiply to 12? If you don't know your multiplication tables, get practicing. But this factor pair sheet will help you. You can use 2 or 6 or 3 and 4. What I'm going to do is I'm going to do 3 and 4 just to show you that you can do whichever one you want. Here's the thing. I know 3 is a prime number, so I'm going to highlight it. I want you to highlight your prime numbers whenever you do your break aparts. Now you have to ask yourself, what makes 4? Well, it's 2 and 2. Note, I'm not going to highlight my 4. I'm going to highlight my 2's. The reason why is because you only highlight your prime numbers. Now that I can't break apart anything else anymore, I'm going to write 12 is equal to 3 times 2 times 2. And that's your final answer. The thing is, that's not all we're doing today. We're going to actually learn how to use that with factoring. Number 2, we want to do prime factorization on the number 24. What I'm going to do is I'm going to say to myself, what makes 24? Well, if you don't know, you can look right on my screen and you can see the factors of the factors of 24. What I'm going to do is I'm going to use 2 and 12. So I'm basically going to say 2 times 12 is 24. I know my 2 is prime, so I'm going to highlight it. Now I need to ask myself, how do I break apart a 12? Well, I believe we did it before, so I could do 3 and 4, but what I'm going to do is I'm actually going to change it up this time and do 2 and 6, because I know 2 times 6 is 12. So 2 and 6. And then I need to ask myself, how do I break apart a 6? It's 2 and 3. I'm going to highlight that 2 and the 3. Now what I want you to do, write 24 is equal to 2 times 2 times 2 times 3. And that's your final answer. If you're like, you know what, I think I got the hang of this, try to do the next one by yourself. So I have to ask myself, what makes 49? Well, to make 49, I simply have to do just 7 times 7. And if you look at my screen, I can't break apart a 7 anymore because it's prime. So I'm going to highlight those. So I can say 49 is equal to 7 times 7. And one thing I'd recommend is don't use x as your multiplication symbol. Use the dot. You'll see why in a moment. Our last term we want to find the prime factorization of is 25x squared. So I have to ask myself, what multiplies to 25? Well, we're not going to touch this x squared yet, but we want to know what makes 25. Well, I know 5 and 5. And I know those are both prime. So I can say 25x squared is equal to 5 times 5, but here's the issue. I have an x squared, so I have to ask myself, how many x's do I actually have? I actually have 2 x's that are being multiplied together, so I'm going to write times x, because I break apart an x squared into x and x. If it was x to the 4th, I can break it apart as x times x times x times x, and so forth. So you're going to see why that's all important very shortly. So what we're learning about today is we're learning about factoring. This is our first factoring technique. Factor is a verb in mathematics. You're not solving, you're not simplifying, you're not solving or simplifying, you're factoring. And to factor means to rewrite an algebraic expression as an equivalent product. So here's the thing. 3 times 2 times 2 is the exact same thing as 12. 2 times 2 times 2 times 3 is the exact same thing as 24. So what we are doing is we are basically rewriting our term or our expression in a different way to make it actually easier to work with. And we're going to learn why it's easier to work with throughout the course of this unit. The first kind of factoring that you always need to look for is a GCF. So you're going to have to do prime factorization. If you're like, I really want to do this prime factorization, there's another way. I'll show it to you. But that's a different video. So this is the first factoring method I need you to look for every single time. And here's your procedure. Take the prime factorization of each term, stack them on top of each other, highlight what is common, that's your GCF, and then put it with your leftovers. Let's do some examples. Look at this table. If you're like, I really need to be organized, rewrite this table for every single question. First thing you're going to do is find your prime factorization of each term. 2, you're going to do your greatest common factor by stacking them. And 3, you put it all together. GCF leftovers. So the first expression we're going to factor is 6x squared plus 10x. So if I wanted to, I can do my prime factorization. So I'm going to do a prime factorization of 6x squared. And to make 6, I can do my 2 and my 3. And I know those are both prime. So I can say 6x squared equals 2 times 3. And now that I have an x squared, I have to write x times x because that means I have 2 x's. All right. Now, I want to find my prime factorization of 10x. One thing I do when I do these questions, color code. So I have to ask myself, what makes 10? Well, if I look at my factor sheet, it's a 2 and a 5. I don't want to use 1 and 10 because that's going to tell me nothing. So I break it apart into 2 and 5. I know those are both prime, so I'm going to highlight them. So I can say 10x is equal to 2 times 5 times x. So we did our prime factorization of our terms. So what I'm going to do is going to make it bigger. Let's hope I can make it bigger. I keep on running into issues with this. Copy it. I'm going to bring it down here. Your greatest common factor, here's what you're going to do. You need to make sure they're stacked on top of each other. You're now going to highlight what each row has in common. They both have a 2 in common, and they both have an x in common. So I'm going to do 2 times x, which is 2x. So my GCF is 2x. So now I'm going to write down GCF in my front and then my leftovers in a set of parentheses. So now let's look. Our leftover here for our 6x squared is 3 times x, which is 3x. Our leftover for our 10x is just a 5. So I can say I have 3x plus 5. That's my leftovers. And that's your final answer. But here's the thing. You're probably asking, how do I know that's right? And two, why do I know it's positive and not a negative or a subtraction? Well, if you look, my 10x is positive. My 6x squared is positive. So I'm going to have to keep them positive the whole time. Also, here's what else you can do to check your final answer. I'm going to rewrite it. So I have 2x times 3x plus 5. I'm going to distribute my 2x to each term on the inside. 2x times 3x is going to be 6x squared. 2x times 5 is going to be 10x, which is exactly what I started with. Let's try to do the next example. So again, we find the prime factorization of each term. So I'm going to find the prime factorization of 3x and 24. Here's what I want you to do. We go to our factor sheet. If we look, number 3 is prime. But here's the issue. What I'm going to do is I'm actually going to break it apart to be 1 and 3, and just know that I'm going to have to write these terms in. So I can say 3x is equal to 1 times 3 times x. Now we're going to do the prime factorization of 24. I think we did it before, but let's just go through the process. Two numbers that make 24, 3 and 8. 3 is prime. What makes 8? 2 and 4, and then 2 and 2, and my 2's are prime. So I can say 24 is equal to 3 times 2 times 2 times 2. Copy it, paste it down here, that way we can do our highlighting. So now I have to ask myself, what's in common? Well, I can see that both rows or both terms have a 3 in common. So I can just say that my GCF for this example is going to be a 3. Now let's do our leftovers. So when I look at my first term, my leftover is a 1 times x, which is 1x. When I look at my second row, I have a 2 times 2 times 2, which is 8. So I can say my leftovers are 1x and an 8. And if I look, my 8's going to be a subtraction because that 24 was being subtracted. Oh no, 1 second. And that's my final answer. So now I can do a quick check if I wanted to. I can do a quick check by just distributing. So if I have 3 times 1x minus 8, I just distribute my 3 to each term. So I get 3 times 1x, which is 3x, and 3 times a minus 8, which is minus 24, which is exactly what I started with. Okay. Now let's go to our next and final example. We want to find the prime factorization of each and every single term. So my 6x cubed, well, I can break apart a 6 into 2 and 3. And again, once you do a bunch of these, you sort of just see the factors in your head. So I can say 6x cubed equals 2 times 3. And I'm going to write 3 x's this time. So 1, 2, 3. Now I'm going to want to do an 8x squared. And if I look, that's a minus 8x squared, so keep that in mind when you rewrite your final answer. I can break apart an 8 to be 2 and 4, and then 2 and 2. Highlight, highlight, highlight. So I can say 8x squared equals 3 2's, so 1, 2, 3, and then 2 x's. 1, 2. And last but not least, I do my 2x this time. So 2x, I'm just going to break it apart into 1 and 2. Make sure you rewrite both of those. I can say 2x equals 1 times 2 times x. Now that we found our prime factorization of each term, we'll be able to find our GCF. So copy, paste, beautiful. Now I have to ask myself, what's in common? Well, I can see that each row, because there's 3 rows this time, they all have an x and they all have a 2. So I can say my GCF is 2x. So when I rewrite this as GCF leftovers, I have 2x. And if I look, my leftovers are 3x squared. 2 times 2 is 4 times x, which is a 4x. And then last but not least, a 1, because I took my 2 and my x away from that expression. Now I have to do my rewriting. So I have 3x squared, and that 3x squared is going to be positive because my 6x cubed was positive. Now I need to write my 4x, and that 4x is going to be a minus. So I have 3x squared minus 4x, and then I'm going to write plus 1 because that 2x was positive when writing it in the beginning. So your final answer is 2x times 3x squared minus 4x plus 1. That doesn't look nice. And that's your final answer. And if you want to do a quick check to make sure that's 100% correct, you just rewrite it. So I have 2x times 3x squared minus 4x plus 1. Distribute your 2x to each term. So 2 times 3 gives me a 6x. Well, x times x squared is what's going to give me my x, so it's x to the third. 2 times 4 is a minus 8, so I get minus 8x squared, and then plus 2x, because 2 times 1 is 2x. 2x times 1 is 2x, which is exactly what I wanted to factor in the very beginning. All right. So that's it for today. If you have any questions, please email myself, Ms. Townsend, or Ms. Jimenez. And there is another way to do this GCF factoring, but I feel, Ms. Townsend feels, Ms. Daniel feels, that if you do it the GCF leftover way, you're just always going to get it correct. Yeah, it does take a little longer, but believe me, you will get it right every single time. All right, have a great day, ladies.